Okay, so today we're diving into this pretty cool concept. It's all about these things called image pyramids. You've heard of these, right?
Yeah, I mean, they're kind of a fundamental idea in computer vision,
Yeah.
especially when you're dealing with, well, trying to get AI to actually make sense of images.
Right. Make sense of what it's seeing. So basically, with these image pyramids, what you're doing is you're taking an image
Mm-hmm.
and you're resizing it. You're creating a bunch of different versions of the same image, just at different resolutions. Kind of like if you had a set of those like Russian nesting dolls.
Yeah, like a visual hierarchy.
Yeah.
And you've got the big picture view at the top, and then as you go down, you're getting more and more detail.
And so, why is that useful for AI? Like, what's the point of having all these different sizes?
Well, think about it like this. If you're trying to detect an object in an image, sometimes that object might be really small, like a tiny little detail, and other times it might take up a huge chunk of the image.
So the model needs to be able to see the object at different scales.
Exactly, and that's where image pyramids come in. They give the AI model a way to analyze the image at multiple levels of detail, so it can pick up on those subtle cues, whether the object's tiny or huge.
So I guess that makes sense for things like, oh, I don't know, like object detection, right?
Yeah.
Where you're trying to find a specific thing, like a cat or a car or whatever.
Yeah, exactly. But it's also really useful for other tasks like image segmentation, which is where you're trying to outline the boundaries of different objects in an image.
So like, say you're a doctor and you're looking at a medical scan. Image segmentation could help you pinpoint exactly where a tumor is.
Yeah. Or in self-driving cars, you need to be able to segment the road from the other cars and pedestrians and stuff.
Right, so it's a pretty powerful tool.
Yeah.
But there's a catch, right? I mean, I'm guessing all this processing power doesn't come cheap.
Yeah, that's the problem with traditional image pyramids. They can be computationally expensive because you're essentially running the same big model on every single resized version of the image.
Oh, I see. So if you have, let's say, 5 different resolutions in your pyramid, you're running the model 5 times.
Yeah, and that can really bog things down, especially as image resolutions get higher and higher and the models themselves get more and more complex.
Yeah, I mean, we're talking about huge amounts of data these days.
Exactly. And that's where this research on parameter inverted image pyramid networks comes in.
Parameter inverted image pyramid
It's
networks.
a mouthful, I know. We can just call it PIP for short.
PIP, got it.
hmm
So what is PIP and how does it solve this problem?
Well, it basically flips the script on how we think about image pyramids. Instead of using a big model on every resolution, it uses smaller models for higher resolutions.
Smaller models for higher resolutions. Now that seems counterintuitive.
I know, right?
I mean, you'd think higher resolution images would need more processing power.
Well, here's the thing. It's all about focusing on the right kind of information at each level. A high-resolution image might have tons of tiny details, like, the texture of someone's skin or the individual leaves on a tree. But it doesn't necessarily need a massive model to understand the broader context. Like, is this a picture of a person or a forest?
So you're saying a smaller, more agile model can handle those fine details efficiently.
Exactly. And then you can reserve the bigger, more powerful models for the lower resolutions,
Right.
where you need that broader context and understanding.
Okay, so it's about playing to each model's strengths.
Yeah, it's like having a team of specialists, each one focused on a specific level of detail.
But how do they all work together? I mean, is it just a bunch of different size models working independently?
There's a bit more to it than that. PIIP has three main components that make it all work. You've got multi-resolution branches, which is where the different size models come in. Then you have these things called cross-branch interactions, which is how the models communicate with each other and share information.
Oh, interesting. So they're not just working in isolation.
Right. And then finally, there's branch merging, which combines the outputs from all the branches.
So it's kind of like having a team of detectives,
Yeah.
each one looking at the evidence from a different angle,
Yeah.
and then they all pool their findings to crack the case.
Exactly. It's a very elegant approach.
So how effective is this PIP approach? Did it actually work well in testing?
The results are really impressive, actually. They tested PIP on a bunch of different tasks: object detection, image segmentation, even image classification.
Yeah.
And consistently, PIP outperformed single branch models and traditional image pyramids.
So it's not just more efficient, it's also more accurate.
Yeah, it's kind of a win-win situation.
That's awesome. Were there any specific wins that really stood out? Like, what were some of the highlights?
Well, one of the coolest things is how well PIP performs with these large vision foundation models. These are like the heavy hitters of the AI world. They're super powerful, but they're also really computationally expensive.
Right, and they required tons of data.
But with PIP, they were able to boost the performance of these large models, while simultaneously cutting their computation almost in half.
Wow, that's huge. So you're saying you can get state-of-the-art results without needing a supercomputer.
Pretty much. It makes these powerful AI models more accessible to a wider range of users.
Okay, so it's efficient and powerful. I'm starting to see why this is such a big deal. But this isn't just about abstract results, right? Are there any practical guidelines for actually using PIP?
Absolutely. One of the key takeaways from the research is that you should prioritize the largest branch in your image pyramid, the one that processes the highest resolution image. Increasing its resolution gives you the most bang for your buck in terms of performance gains.
Makes sense. You want to make sure the model that's handling the most detailed information has what it needs to do its job well. And that brings us to our next question. How do those multi-resolution branches actually work together? You mentioned cross-branch interactions. What does that actually look like?
So it's like a really sophisticated communication system between the different models. PIP uses this thing called deformable cross-attention, which allows features from different resolutions to interact and influence each other. Imagine the model is focusing on, say, a dog in a low-resolution image. With cross-attention, it can then direct the higher-resolution models to zoom in on specific areas of the dog, like its eyes or its collar, to capture finer details.
So it's not just a one-way street. The models are actually working together, refining their understanding based on what the other models are seeing. That's pretty amazing.
Yeah, it's a really cool concept. And it makes you wonder if this kind of multi-resolution processing could be applied to other types of data too. Like, what about audio or text?
That's an interesting thought. Like, you could have smaller models focusing on high-frequency sounds in a piece of music, while larger models capture the overall melody and rhythm.
Exactly. Or in natural language processing, you could analyze a sentence at multiple levels, with smaller models focusing on individual words and their grammatical roles, while a larger model grasps the overall meaning and context of the sentence.
It's like having a team of linguists, each with their own area of expertise, collaborating to decipher the subtleties of language. It makes me wonder if this multi-resolution approach is mimicking how our own brains process information.
That's a fascinating parallel, and it speaks to the potential of PIIP's approach. By drawing inspiration from the way our brains handle complex data, we might be able to unlock new levels of performance and understanding in AI systems.
That's a really cool idea. So I remember you mentioned that PIP was also applied to multimodal understanding, which involves processing information from multiple sources, like images and text. Did the research dive into that at all?
Yeah, they actually developed a model called PIP-LLaVA, which combines the strengths of PIP with the power of large language models.
LLMs, right.
Mm.
I've heard a lot about those lately. They're capable of some pretty incredible things.
Oh yeah, they're amazing. They can write poems, generate realistic dialogue, even translate languages.
So how do they fit into the PIP framework?
Well, it's all about combining the best of both worlds. PIP-LLaVA uses the multi-resolution branches of PIP to extract visual features from images at different scales. And those features are then fed into the LLM alongside textual information.
So it's like giving the LLM multiple viewpoints on the image, which helps it to understand the scene more comprehensively.
Exactly, and the results are really promising. PIP-LLaVA outperformed other multi-resolution approaches on a variety of multimodal benchmarks, including things like visual question answering, where the model has to answer questions based on an image and some accompanying text.
That's impressive. This really shows that PIP's approach isn't limited to just image processing. It has the potential to enhance AI systems across multiple modalities. What are the practical implications of all of this? How can PIP benefit us in real-world applications?
Yeah, so you're asking about real-world applications for PIP, right?
Yeah, exactly. Like, all this sounds really cool in theory, but how does it actually translate into something that benefits, everyday people?
Well, one of the most exciting things about PIP is its potential to make AI more accessible. You know how we're always talking about the power of AI and how it's transforming everything?
Yeah, it seems like every day there's a new breakthrough.
Right, but a lot of those breakthroughs are happening in the cloud on these massive servers that require a ton of processing power.
Which means most of us can't really access them directly. We have to rely on companies like Google or Amazon to provide those services.
Exactly, but with PIP, because you're not using these giant models all the time, you can actually run pretty sophisticated AI models directly on smaller devices like smartphones, tablets, even those little smart home gadgets.
So you're saying my phone could potentially have the same level of image understanding as a big server? but without draining my battery in 5 minutes.
It's definitely a possibility. It all comes down to efficiency.
That would be a game changer. Imagine all the things we could do if our devices were that smart.
Yeah, like imagine your smartphone could instantly identify plants and animals, or provide real-time feedback on your exercise form.
Or even help you navigate complex environments using augmented reality, all without needing to send your data to the cloud.
Exactly. It could really open up a whole new world of possibilities.
And not just for convenience, but also for privacy. I mean, if our devices can process our data locally, we don't have to worry about it being sent to some big corporation.
Absolutely. That's a huge concern for a lot of people these days.
So efficiency, accessibility, privacy. Are there any other benefits we should talk about?
Well, another important aspect is sustainability. Training and running these large AI models requires a lot of energy.
Yeah, I've heard about that. It's like those models have a pretty big carbon footprint.
Right. But with PIP's efficiency, we can potentially reduce that footprint significantly.
That's awesome. It's not just about making cool technology. It's about making sure that technology is sustainable for the planet.
Exactly. It's about finding ways to advance AI while minimizing its impact on the environment.
Now, with all the excitement surrounding PIP, I have to ask, are there any limitations or challenges we should be aware of? I mean, no technology is perfect, right?
Yeah, of course. One potential challenge is the complexity of managing multiple models with different sizes. It requires more careful tuning and optimization to make sure all the pieces are working together harmoniously.
I see. So it's like coordinating a team of specialists instead of having one generalist handle everything.
Right. It requires more finesse, but it can lead to better results in the end.
And while PIP offers significant efficiency gains, are there ever situations where pushing for extreme efficiency could lead to a trade-off in accuracy?
It's possible. It's always a balancing act, finding that sweet spot between resource usage and desired performance.
So it's about understanding the trade-offs and choosing the right configuration for the specific task at hand.
Yeah, exactly. And it's worth remembering that this research is still relatively new. There's a lot more to explore and discover about PIP and its potential applications.
Well, this has been an incredible deep dive. I feel like I've gained a whole new understanding of how AI is evolving and the exciting possibilities that lie ahead.
It's been a pleasure sharing this journey with you.
So to all our listeners out there, if you're interested in the cutting edge of AI and how it's shaping our world, keep an eye on PIT. It's a technology with the potential to revolutionize how we interact with machines and unlock a whole new level of intelligence in our devices. Thanks for joining us on this deep dive. Until next time, keep exploring.
Yeah, I mean, that's the big question, right? Like, it's great to have all these impressive results, but how does PIP actually benefit people in their everyday lives?
Yeah, that's what I'm curious about too. Give us the practical implications.
Well, one of the most exciting aspects is its potential to make AI more accessible. Think about all the devices we use on a daily basis. Smartphones, tablets, those little smart home gadgets, they all have limited processing power compared to those massive servers used in data centers.
Right, right. And right now, a lot of the coolest AI applications rely on those powerful servers in the cloud, which introduces latency, privacy concerns, and well, it just doesn't work if you're offline.
Exactly, exactly. But with PIP, you're not using these huge, power-hungry models all the time, so you can actually run sophisticated AI models directly on those smaller devices, which means faster processing, more responsive applications, and potentially even greater privacy.
So you're saying, like, my phone could potentially have the same level of image understanding as a big server, but without killing my battery in 5 minutes.
Yeah, I mean, it's a real possibility. Think about it. A world where your smartphone can instantly identify plants and animals, give you real-time feedback on your exercise form, or even help you navigate complex environments using augmented reality, all without needing to send your data to the cloud.
That's incredible. It's like AI that's actually portable and integrated into our lives,
That
not
would
just
be
up in some data center.
Exactly. It could be a real game changer.
So we've got efficiency, accessibility, privacy. Are there any other benefits we should touch on?
Well, another important aspect is sustainability. Training and running these large AI models requires a ton of energy.
Yeah, I've heard about that. Like they have a pretty big carbon footprint.
Right, but with PIP's efficiency, we can potentially reduce that footprint significantly.
That's fantastic. It's not just about making cool tech. It's about making sure the tech is sustainable for the planet, right?
Absolutely.
Okay, so PIAP sounds pretty amazing, but I have to ask, are there any downsides, any challenges we should be aware of?
Well, sure, every technology has its limitations. One potential challenge with PIP is the complexity of managing multiple models with different sizes. It requires more careful tuning and optimization to make sure everything's working together smoothly.
I see. So it's like coordinating a team of specialists, right? Instead
Yeah.
of having one generalist handle everything.
Yeah, exactly. It takes a bit more finesse, but it can lead to better results in the end.
Makes sense. Now, you mentioned that PIP offers these significant efficiency gains, but are there ever situations where pushing for extreme efficiency could lead to a trade-off in accuracy?
Well, yeah, it's possible. I mean, it's always a balancing act, right? Finding that sweet spot between resource usage and performance.
So you have to understand the trade-offs and choose the right configuration for the task at hand.
Exactly. And it's important to remember that this research is still relatively new. There's a lot more to explore and discover about PIP and its potential applications.
Well, this has been an incredible deep dive. I feel like we've really uncovered some groundbreaking stuff here.
It's been great talking about it with you.
So to all our listeners out there, if you're fascinated by the future of AI and how it's going to impact our world, keep an eye on PIIP. It's a technology with the potential to revolutionize how we interact with machines and unlock a whole new level of intelligence and capability in our devices. Thanks for joining us on this deep dive. Until next time, keep exploring.